Jam pass question 2001. Question number 43. The primary coil of a transformer has N turns or known turns and is connected to 120 volts AC power line. If the secondary coil has 1000 turns and a terminal voltage of 1200 volts, what is the value of N? Our question today is centered on transformer, on a transformer. Anytime you are giving question in transformer, you don't need to panic, just smile. It's one of the easiest things you can solve in physics. Okay, let's see the clue. Let's give ourselves that confidence that we can do it. There is a general standard for transformer. The standard is this. Irrespective of the fact that a transformer has two coils, a primary coil and a secondary coil, there is something that remains fixed in both coils, and that is the power. The electric power is constant. Okay, this is what I mean. Just do this. Say power in primary coil. Power in primary coil is equal to power in secondary coil. That's the first thing you need to say, so as to gain basis for finding solution for that. Okay, observe. In the electrical world, power is equal to IV. Current multiply voltage is R, electric power, IV. Okay? Then observe. I can now say I in primary, V in primary is equal to I in secondary, V in secondary. This is the same thing as power. Current times voltage is power. So current in primary, voltage in primary, current in secondary, voltage in secondary. Then paying attention. Then this is the variation that happens. Apart from the equality we've explained before now, there's a variation. If your primary coil has high currents, then the voltage will step down. It's a kind of balance. In the primary coil, if the primary coil has high current, then it will have less voltage. That's the game. Then coming to secondary coil, because in the primary coil the current was less, so in the secondary coil the current will now be what? High. Okay, if the primary has high current, the secondary will have low current. If the primary has low voltage, the secondary will have high voltage. That's the alternate nature of transformer. But at the end, we'll get the same power at both coils. Okay, so what I mean. Yeah, in primary coil, we have high current, low voltage. Then when the current gets here, in secondary, it becomes low. And the voltage becomes what? High. And that is step-up transformer, where the voltage is raised high. Step-up transformer. Okay, then let's observe the type of transformer we have in our question today. Okay. However, most times we solve this as ratio, transformer ratio. Okay, let me get that linear equation into ratio. Observe. I want to get all currents one side and all voltage the other side. Okay, for current to stand this way, I want to get this I that way. It's being multiplied with V, therefore I will divide both sides. Dividing both sides, I have I, current in primary over current in secondary. So this one is no more there. I've taken it under here, equal to Vx is already here. Then this one will come over here, Vp. So Vp is no more there. Then observe, this equation and that equation are the same. When you do cross and multiplication, you're getting your Ip Vp back, Is Vs back. So they are the same. So we'll consider this formula transformer ratio, where you keep them in form of ratios. Okay, let's see. I now have Ip over Ix equal to Vx over Vp. Then there is another term that is always involved in transformer ratio, and that term is number of turns. Number of turns of wire or number of turns of coil. And that term is synonymous to voltage. Okay, paying attention. See what I mean by that? The higher the voltage, the higher the number of turns. Or let me say it the other way. The higher the number of turns, the higher the voltage. It's the number of turns that increases the voltage. When you have more coils of wire, you are increasing the voltage. The more coils you make, the more the voltage. Then we can now build this ratio further. Ip Ix equal to Vx Vp. Since number of turns of coil is the same as voltage, I can also say Nx Np. Notice the number of turns copies voltage and not current. It copies the voltage and not the current because the number of turns is the same as the voltage. The more coils you make, the more the voltage. So these are transformer ratios. Yeah, most times it's within these three. Then let's now see the parameters favored by our question. In our question, we have volts. In our question, we have number of turns of coil. So we're using this. Number of turns of coil. So these two ratio is what we use in today's question. So we can now solve. Okay, let's solve. Recall this is secondary and that's primary. Then going back to our question, it says that primary coil has n turns. Then this is the n we're looking for, question mark. This number of turns in primary coil. And it's connected to 120 volts AC. Then this primary was connected to VP. This voltage in the primary coil, 120 volts. 120 volts. Then if the secondary coil has 1000 turns, this number of turns in the secondary, 1000. Okay? And the voltage at that terminal is 1200 volts. Then we are looking for N. I want you to observe something. Notice, in our primary coil, the voltage is 120 volts. In the secondary, to be higher. That's what we said earlier. In the primary coil, the voltage is small. So in the secondary, to be very what? High. Then recall, anywhere the voltage is high, the number of turns of coil will also be what? High. Then remember, it's the secondary that has more voltage. Therefore, the secondary is expected to have a higher number of turns of coil, 1000. The primary has less voltage. Therefore, it should also have less number of turns of coil. If at the end of the day, I get something more than 1000, total failure. It's against the logic. For the fact my primary has lower voltage, it should have fewer number of turns of coil. That's the logic we explained earlier. Then let's solve. Then let's make NP the subnet of the formula, get it up and get this one down. So we're having NP is equal to NX. Then this comes down to replace it, cross and multiply. Vx, cross and multiply. VP will go and join the other one, VP. Then we can now solve. Then NP is equal to NX, 1000. My VP, 120 all over Vx, 1200. So this goes for that. We have 10 here. 120 will go in here. We have just 10 here. Then 0 cancels 0. Therefore, the number of turns in primary is just 100 turns. 100 turns. Just like we said, we're expecting lower number of turns of wire here because we have lower voltage. We already have higher number of turns of coil there because we have a greater voltage here. Then going back to our question, we can see the best option there is option B. Please stay tuned, relax as we forge ahead.